Welcome to the Workflow Show. This is Nick Gold, and this is episode 209, an interview with Gary Watson, the Chief Technical Officer of Nexsan. And I'm joined today by our new co-host, Jason Whetstone. And Jason, welcome to our organization. Jason is our new solutions architect in our national or pro video group.
Thank you, Nick.
How are you today?
I'm great.
So you've been here for about 2 months now.
It's been about 2 months. It's been a very exciting time. Lots of ramp up on technologies that I'm very interested in, but not necessarily familiar with. So.
Oh, don't be so modest, Jason. We brought him into the organization after knowing him for a number of years. He worked for JPL Productions in Pennsylvania and has lots of hands-on experience with storage, archive systems, media asset management as an administrator. And he seemed a good fit for the team. We are no longer with Merrill. He has been a great host for almost, 2 years now? Yeah. But Merrill is no longer with our organization, and he has moved along with his family to Nashville. I think it's to pursue a country music career, if I remember correctly. I believe that's what his LinkedIn profile said. So we wish him well. We'll probably see him on Grand Ole Opry pretty soon.
And don't worry, there'll be plenty of mentions of Vogon poetry and, Hitchhiker's Guide to the Galaxy on this end of things. So.
Yeah, absolutely. We can keep that going with Jason, no problem. So
I've been Hitchhiker's Guide fan ever since high school. So
yeah,
definitely do the towel on May 25th.
Yeah,
so.
Exactly, right? I mean, we are geeks, and we like our geek references, to be sure. So speaking of geeks, Gary, I hope that's not offensive to you at all.
Well, hey, guys! This is Gary Watson from the Nexsan side. I'm actually sitting here teaching myself the banjo because I'm going to also follow in the footsteps of going to Nashville because I didn't know that was an option for computer guys. Now that I know it's an option, I'm right there.
We encourage it, and maybe you can play a little during the episode today, Gary. We encourage that. So, Gary, we met probably the first time, almost 2 years ago, and maybe I'll give a little backstory. I think our first we had known about Nexsan. Nexsan is one of our primary and leading storage vendors of hard drive and disk-based storage solutions. They play into a lot of the storage area networks that we do. They have a line of network-detached storage devices, or NASs, aka file servers, and they've been a fantastic vendor for us for a number of years. And I think, again, despite having known of you guys for a great number of years, our first dealings were during the flooding in, where was that? In Taiwan or Thailand. I'm sorry, the Thailand flooding that disrupted global hard drive supplies for what seemed like almost a year. And somehow you guys came to our attention as the ones who could still get hard drives and weren't having a problem with supply. You remember that, Gary?
Oh, I remember it. We had all kinds of problems. We just tried to make sure our customers never knew about it.
See, that's what we love about you guys. Just obscure what's really going on in the background and keep us happy. But frankly, that's generally a good thing. So we began working with you guys, and we loved the products. And again, we were mostly using your E-Series fiber channel RAIDs. They were going into a lot of the SANs that we were doing, and it's just been this marriage made in heaven ever since, and we've done a lot with you guys, and our clients that we've brought you guys into are generally quite ecstatic with their Nexsan disk.
I think our service department is quite ecstatic with it as well. It's a pretty neat series of storage. It's very dense. There's a lot of drives per square inch, I would say.
Oh yeah, no, they're fantastic. Our guys have loved them, and they've just worked wonderfully. So Gary, maybe you can tell us first just a little bit about yourself and your genesis at Nexsan. You, if I remember correctly, are one of the founders. And
yeah, that's right, yeah.
So how did that all begin? I mean, was this just a bunch of you engineers sitting around let's make a disk storage company?
Actually, the details are much more sordid than that. Let me tell you the story. So in the 80s, I designed tape and disk controllers for mini computers. And then towards the end of that run, I designed what today would be called a RAID 0 controller. We didn't have that name. That's what it was. So it basically striped a bunch of drives together. And that was my last project at a company. And then another company wanted to get into the enclosure business because they were making RAID enclosures for people like Hewlett-Packard and DEC. And they thought, well, hey, let's make our own brand of RAID systems. So they hired me to come in and be the RAID product manager. I worked for that company for a long time. And the politics started getting a little bit thick for me there, so I asked to transfer to their operation in the United Kingdom. And so they had a factory in Nottingham, England, and I was single. That sounded like fun. So they sent me over there to start a European engineering team, and that worked really well for a couple of years. And then in a sort of a corporate shakeup, they fired my boss, the managing director of the UK facility. And he called me the next day and said, "Do you want to start a new company?" And that sounded really good to me. I mean, how hard could that possibly be, right?
Youthful naivete.
Yeah. So again, I was single, and I had money, and so me and him started the company. And my co-founder, his name is Martin Body. He was with us as our first CEO for the first 6 or 7 years or whatever. He handled the money side and the sales side, and I handled the design. So in the first couple of years, I designed all the boards and worked with a contractor to design the chassis. We ultimately hired that contractor to be an employee, and then we started hiring actual engineers with more talent than me to do the boards and the software and stuff. And so that was in 1999. And then in 2000, we acquired a small company in the UK that had a RAID controller stack for ATA disk drives, which you call desktop drives. And we expanded that technology to do an 8-drive box. So it was 8-drive rack-mounted system for ATA. So like a data center style ATA disk box. No one had ever done that. Then we made a 14-drive version. And then when things really took off is when we made a 42-drive box, which was called the ATA Beast. And the ATA drives in those days had 6 times the density and about 10 times cheaper cost per terabyte than typical enterprise drives did. So the trick was trying to make sure you got enough reliability out of these drives so that they would fit into a data center. And that's what our claim to fame was. We came up with a lot of techniques to do that. And then we updated the product and came out with a SATA Beast, which a lot of people are very familiar with. It's 42 drives with SATA drives. And then the product you were talking about is the next generation of that, the E-Series, which was where we had 3 drawers of 20 drives each to give you 60 drives in one shelf. We just updated that family to what we call the E-Series V, so it's just like a midlife kicker with faster controllers and stuff. Still 60 drives, and we just released a 6-terabyte drive. So now you've got 360 terabytes in a 4U shelf.
Which is like nuts.
It's just
history.
Crazy, yeah.
So yes, we have a lot of experience with the E-Series. We'll get more into that, but was Nexsan really always bent on high density from the get-go? Was that, kind of one of the fundamental principles, that and using kind of the less expensive, highly dense drives on, that were available for the times as well? I mean, what was the philosophy of the company's storage?
Well, really, we wanted to make storage so inexpensive that it could be used to replace tape in most cases. So if you think about the types of applications we routinely talk about today, using it for video, using it for closed circuit television recording, using it for backup targets, that stuff was unheard of in 1999 and the early 2000s because disk systems were just too expensive. So by being disruptive with the density and the price, we could cut the power consumption. So it was, within striking distance of a tape library of the same capacity. We could cut the rack space requirement so it was a reasonable amount of space, and we could make it cheap enough so maybe it wasn't as cheap as tape, but it was cheap enough that people said, okay, this is cheap enough to be used for tape replacement operations. And so over time, as we gained more credibility in the data center, we also started attacking the performance side of the market. So that was a different skill set, and we started doing that maybe 5 years ago by starting to do work with 10,000 and 15,000 RPM drives and solid state drives and things like that.
And the company, what was it, about a year and a half ago, underwent a corporate shift of sorts. It was acquired by Imation.
We were acquired by Imation. Imation is about $1 billion company. You may know them as the owners of the TDK brand. Also, they sell a lot of media under the Imation brand. They private label tape media for a number of large companies. So, they make hundreds of millions of dollars worth of like LTO cartridges a year. So they didn't really have much of a storage business, but they wanted to be in disk storage. They did a couple of small projects, but nothing really serious. And so they wanted to buy a turnkey storage company and we were available to be acquired. We were doing pretty well, but this gave us an opportunity to have a much larger parent corporation to bring in a bunch of capital to help us expand. The other alternative was doing an IPO, and that market is too much tumultuous to say the least. So we got with them, and they made us a good offer, and so it's been a very gentle transition. They kept everybody for the first year, and we've had some management changes, but basically it's been a thing where they've added to us rather than subtracted. So they've added facilities, they've added people. So it's been a very, very helpful transition. And as I like to tell people, we're all the same people doing the same stuff. We just drive nicer cars now.
Hey, I'm all about it. And the biggest change that we noticed was frankly the color of the accent on the front of the units went from being kind of a yellowish gold to red. I mean, that was really the biggest change we saw from an integrator perspective. And I mean, essentially everybody that we interacted with was still there, and the quality, new products have come out that are even better. And, so I mean, it was, it sounds like it was really helpful to you guys on the backside of things, but it was just a very consistent experience for us. And I can't always say that about acquisitions amongst vendors that we've worked with before.
Well, I guess one of the differences, Nick, is that if we were acquired by a big company, let's say, for example, EMC, we would be assimilated into the Borg really fast, right? So, and then within a short period of time, most of our products would probably disappear and all of our people would dissipate within their organization. In this case, they didn't have a storage company already, so we became the storage company.
Right.
And it's actually more the other way around. We've been poaching their staff. So a lot of our added personnel came from Imation. And they had a lot of really great people who were off selling tape cartridges, and we taught them how to sell RAID systems, and they're doing way better doing that because it's more interesting and more fun. And Imation also had a number of worldwide facilities that they gave us access to. And so one of the things you're going to see a lot more of is our support 24/7 worldwide is getting much better. And we have this thing where we want to make sure when you call the phone, you're always talking to an Imation Nexsan employee as opposed to a third-party call-taking company.
That's fantastic.
Yeah.
And I mean, frankly, your support is one of the reasons why both our techs and our clients love you guys. So, I mean, to imagine you taking something that frankly was already recognized as being extremely good and saying, how can we make it better? We love to hear that. That's fantastic.
There was an excellent slide that one of our managers showed on one of our presentations recently where they basically said, okay, what are people's perceived quality of laptops? And Apple was right at the top. And then everyone else sort of worked their way down to the bottom, like Dell was near the bottom. And when they actually looked at the percentage of time the systems fail, they're all pretty much the same. All laptops pretty much fail at the same rate. The difference was Apple's support is so easy to use and so friendly. Everyone has bad experiences, but generally speaking, anything you ever do, you just go to the Apple store and they take care of it, is in sharp contrast to the support you get from a number of other laptop vendors. And that gives people the perception of a much higher quality product.
Well,
That's right.
And you talk about these things tend to happen at the same rate and support is very influential. But one thing I can speak to is your guys' products don't fail at the same rate as some of the other vendors we've worked with over the years. And I mean, yes, we know that when we're selling mass amounts of hard drives with complex RAID controllers behind them, things can go wrong, especially because we sell so many across so many clients. But you guys put more into them, and we can talk about the E-Series now. You do a lot of pre-testing in-house to ensure that failure rates are going to be as low as possible. Can you go into some of kind of that TLC you apply to each and every hard drive and kind of what your methodology is to make sure people get, the best possible experience out of those RAIDs, so frankly they don't have to call you as often just for even standard types of failures?
Well, let me back you up the clock a little bit. One of the things that I like to remind people is this overnight success we've had with the E-Series. It's 15 years of overnight success. It represents an iterative generation after generation of developing high-density arrays We shipped our first high density array in 2003. So we've been doing that for a long time, and we're getting very good at making those systems reliable. And it's not that there's one big secret thing. It's a whole bunch of little things that you learn along the way about designing the chassis the right way, about using the right kind of disk drives, developing the right kind of techniques for telling whether or not a hard drive will be reliable in a system. As an example, we developed something called Stress Test. And Stress Test is a program that lives on the firmware of the RAID controller. And what it does is it automatically runs a test program against all the drives in the box. This is used in engineering qualification and manufacturing. And you run this test for a couple of days for a typical test. And after a couple of days, you look at the results. And normally, none of the drives will have actually had an error in a couple of days. Yet, maybe one or two of the drives in that time period will exhibit signs of weakness. And how we measure that is by measuring the amount of time that it takes a drive to do commands. Drives that take a little bit longer to finish a command, given that you give the same set of commands to all the same drives, the slower drives are having trouble positioning on the head, either because they're mechanically out of alignment or one of the heads is weak. And we have found that that's a really, really good way to tell if a drive is going to be reliable in a high density, high workload environment. And we take those drives out, even though they don't have any errors or anything, we take them out, return them to the manufacturer, and we call that our drive screening process. And that's something we do. It's one of the many ways that we do reliability. Another thing that's happening in the industry is if you buy a storage array from most companies these days, it shows up on your dock as two cardboard boxes, one with the storage shelf in it and the other with the hard drives. Those two boxes have never seen each other until that moment. And in our case, it's different. When you actually buy the system, it's tested with the drives that are going in your system. This is going to guarantee that it's the test results and the chassis will match as closely as possible. I'll give you one example why that might matter. So you take a high density box, it's got, like, in our case, 60 drives. Let's suppose you have a drive that vibrates more than it should. It works, but it vibrates more than it should. At the disk drive manufacturing house, they'll never notice that because it's just sitting on a big Lucite block by itself being tested. And as far as they're concerned, that drive is fine. They go ahead and ship it. The problem is when you stick it into a high density box, that extra vibration is bothering all the drives in the vicinity, and it will make all the other drives either go slower or possibly even fail. So by testing them together, you get to catch those kind of scenarios, or you catch drives that are unusually sensitive to vibration. And the vibration, it's not a question of the amount of vibration. When you put a bunch of drives in a box together, the vibration frequency is higher than if they're on their own on a desk. And so the higher frequency vibration, this is a way of determining whether the drives have an issue with it. So not getting into the technical weeds here, but basically it's one of the things we do to screen out, bad drives. And we also have very strict controls on drive vendors and revisions. We don't let the vendors change revisions of anything. If they want to change the revision of a part or a subassembly or the firmware, it has to go back through qualification again. And this is not just a perfunctory thing. Very frequently, they'll make a change to a drive, which actually causes it to fail qualifications. So that's why it's very important to be careful where you buy your drives and try to make sure that you're careful about the firmware revisions of the drives, because it can make a huge difference to whether they're reliable or not. So that's some of the stuff we do. And we also learned some tricks, like we mount the drives in back-to-back counter-rotating pairs to help cancel out the vibration. We're very careful about cooling. And on the E60 family, we started doing something called active cooling, where the fans are speed controlled. So normally in a normal computer room, there's normal temperature, 70 degrees or so Fahrenheit. And if everything is working normally and you're not doing anything unusual to the system, the fans will be running about half speed. So running fans half speed accomplishes 4 basic things. Number 1, it uses less power. Number 2, it's quieter. Number 3, it reduces the amount of vibration the fans cause. And number 4, it makes the fans last about 10 times longer. So those are there's about 100 things like that I could list for you. But that's a quick little run through of some of the things we have to think about when we make boxes like this. And then, of course, there's a couple 100,000 lines of firmware that sit on top of that take care of things like scanning the drives for errors and dealing with error situations when they occur.
Wow.
Yeah, I mean, when people ask us what makes one raid different than another, I'm just going to have them listen to this episode of the podcast. And we basically tell a little light version of that story when we explain this to our customers, but we see it.
Yeah,
we
so
see it.
Amazingly stringent, just testing on your end, and also then the relationship that you have with the drive vendors is also a really big piece of that puzzle as well.
Well, and in the early days, when we first started doing the enterprise ATA stuff, there was no such thing as enterprise ATA drives. So we worked with one manufacturer, was very willing to work with us to try to improve their product so it would work well in that environment, because they thought that was going to be strategic going forward. And it turned out they were right. And we were early, very early on that technology curve. And so we worked together, and they made changes. We made changes. We very much cooperated. And they've been mostly our drive vendor of choice, even though they've been acquired a couple times. And then we occasionally qualify other drives. And lately, we spend a lot of time trying to qualify solid state drives, because that's the wild, wild west again. The solid state drives are changing. Every few months they make changes to the drives and the technologies, and the vendors pop up and pop out. So it really is keeping us busy trying to figure out what drives are good and what drives are not good in the SSD world.
Well, let's talk about drive technology for a moment, and let's start with hard drives, because we've obviously seen a lot of capacity expansion, and you alluded earlier to 6 terabyte drives coming online now. We've obviously seen the transition between ATA or parallel ATA and IDE drives to SATA, and now you guys in the E-Series Vs and VTs are shipping nearline SAS as kind of the standard. And again, we're seeing, things coming down the pike like, helium drives and things like that. Can you give us, you're highly technical when it comes to this stuff, and you've seen it for many years now. Where are we in the progression of hard drives? What should we expect to see? What is kind of the difference between especially SATA and nearline SAS, and what does that give to the customer? School us, Gary, school us.
Okay, so here's the thing. There's a lot of questions there. Let's talk about the SATA versus nearline SAS thing. So we had been kind of sloppy around here in using a nomenclature. We'd talk about SATA drives, and by that we meant 7,200 RPM drives, and we'd say SAS drives, and by that we meant either 10K or 15K drives. We've supported both of those for a long time, but a lot of our customers have pressured us to try to switch from SATA to nearline SAS. The actual drive mechanism is the same, but the electronics are a little bit better. I mean, it's very technical differences, but the electronics on a nearline SAS drive are a little bit more sophisticated.
You get that enterprise class, that is what they're typically referred to, the enterprise class drives with the...
But the actual physical drive is the same between those SATA drives that we were using and the nearline SAS drives we're using. The only difference is a different I/O card on the drive. So the actual thing that's you have to worry about is the HDA mechanism, the heads and the disks and stuff, and the read-write channel. All that stuff is the same between the two types of drives. I mean, literally the same components. The difference is whether it has a SATA chip or a SAS chip on the board. SATA gives you a few advantages in error correction and being better on the bus when you have a large number of drives contending for access to the media, the SAS media I'm talking about. The SAS drives are better behaved, so we can get a little bit more throughput. But the difference to the user is pretty negligible. But the main thing that happened was the price difference between the SATA and the nearline SAS got down to just peanuts. So we're able to tell people, hey, we'll switch to nearline SAS with a negligible cost impact. And because it's really more of a sales thing. It helps with sales because some sales tenders require the nearline SAS as part of the spec. Mm-hmm. So we figured there's no reason to fight that battle anymore. So even though we know that the drives are there's no reliability difference that you're ever going to notice between the SATA and the nearline SAS, but they're the same price. You might as well go with the one everybody wants, right? So we switched to nearline SAS, and then in future generations of the product, we might drop support for SATA. I mean, officially, we don't have any support for SATA in the new box anyway, although the electronics would still work if you tried it. But in the distant future, we may be using silicon that no longer supports the old-fashioned SATA interface. So we had to make the transition at some point, and it just seemed like this was a good time to do it. Now, in terms of the helium, the new helium drives, 6 terabyte drives, this is the tip of the iceberg. They're talking about some capacity points. I'm not allowed to repeat sort of the roadmap, but this is nothing. They've got some really super ambitious plans for hard drives.
Gary, can you tell us like what makes a drive a helium drive? I think some people could probably use that insight.
So at some point, the drive vendors decided that using helium instead of air inside of a hard drive would give them better aerodynamic properties. They could make the head fly lower on the media. And so the helium drive actually is a sealed chamber with helium inside, and it no longer has a little filter which allows outside air to go in and out of the drive. It's now a sealed container.
Right.
And that's just one vendor's approach to the problem. It may not be the whole solution. They also have done a lot of other things in the drives to get the higher density, but there's a whole long series of things they've got planned to increase density way beyond the 6 terabyte number. And I get asked the question a lot, well, don't you think the whole world is going to go solid state? And I keep seeing the difference in cost per terabyte of these new spinning drive systems versus SSD, and they're still miles apart, 20, 25 times difference. So I think for capacity optimized applications, spinning drives are going to be with us for quite some time, especially with the new roadmap that's underway. And especially considering the fact that these drives transfer, a couple of 100 megabytes a second per drive. So, the actual sequential transfer rate of spinning 7200 RPM drives is very, very good. And switching to solid state doesn't really help you with that much. So if it is a sequential workload, we're seeing the spinning hard drives proceeding very well going into the future. And furthermore, the 3.5-inch form factor appears to be the winner for quite some time, and just in terms of cost per terabyte or in density per cubic foot. Although we do have also recently we have an enclosure that supports 2.5-inch drives, but really for the bulk of our market, especially in the video space, we expect the 3.5-inch form factor to be the winner for a long time.
Wow. Yeah, I know that's a pretty common misconception with these high-end video applications. A lot of people are thinking, well, why not just do SSDs? I mean, they're so much faster. And this is really a great discussion, for those people who are thinking along those lines.
You know what? The word faster is an interesting word. We spend a lot of time around here trying to decide how to define what faster means. But I'll give you a couple of interesting factoids about solid state. Most solid state drives are pretty good at reading. But you will find if you take several different types of solid state drives and try to write to them, especially try to write to them for any length of time. So let's say like it's a 100 gigabyte drive, you write 100 gigabytes of data to it in a row, then all of a sudden the performance is going to change. Now a really expensive, high-tech, high-end drive, it won't change very much, maybe 30, 40%. But an inexpensive, high-density drive, maybe the kind of thing you get from a retail establishment or on the internet, it may drop in performance 99% because it's having to do so much garbage collection in the background, and it really can't accept new data very fast coming in when it's doing that. And that performance stays really low until such time as you leave it alone long enough for it to recover. And that can be quite some time. So, like 30 minutes or something. So in a system that's going to be used heavily, you have to be very careful about what type of solid state you have to make sure that its steady state write performance is adequate for what you're trying to do. And remember that video is all about writes. So you got data coming in, you're going to load in 45 minutes of uncompressed HD video. You're writing and writing and writing and writing and writing in a nice long string, and you may very well run up to that limit of how much the drive can take without having to do garbage collection. And then all of a sudden the performance drops and you start dropping frames,
Sure.
An hour into the project while you've gone out to go get lunch, right?
Mm-hmm.
That's problematic. And, the other thing is just the cost per terabyte. I mean, SSDs are still considerably more expensive, and after what you're describing of them not necessarily in any way, shape, or form being ideal for video applications, which, again, are very, sequential in nature. Again, we're writing out long streams of video files and reading off large chunks of video at once,
And Nick, the thing is, Nick, also writing wears out drives. So A lot of the drive technologies, let me just tell you what the drive technologies are. You have the MLC, multi-level cell flash drives. They typically have a durability of a few thousand erase cycles. So you take the capacity of the drive times a few thousand, depending on what the spec is. That's how much data you can write to that drive before it burns up. And by burns up, I mean it'll just brick. It'll stop working. So writes actually wear them out. It's like each one of these bits in the system is effectively like a little battery that you're charging and discharging and charging and discharging. Just like a rechargeable battery and anything else, it can only do so many recharges before it stops working. Then they had something called Enterprise Multi-Level Cell, and the newest generation of that is actually very good. They've got those up into the sort of 100,000 range of erase cycles, and that's usually enough for almost anything. And then the older technology, single level cell, SLC, flash drives, which is what they used to call enterprise flash, is actually designed so that you can just pound on it, day and night for 5 years without wearing it out. And the trade-off is price and density. So the SLC devices are very expensive, and they're so expensive that they're essentially being phased out because the new generation enterprise MLC devices are good enough for most people. And there's no reason to spend the tons and tons of extra money for SLC technology, except for the very most demanding applications. And then lastly, and this is just applicable to using it as a cache device, we have a product that uses a lot of solid state flash, but it uses RAM for the most demanding part of the cache because RAM does not wear out and RAM is way faster. But the downside, of course, is RAM is very low density and very expensive. So we use RAM for the most demanding caching applications for solid state. Then we use SLC or the best eMLC devices for the next tier down. And we're not currently doing anything with MLC in our type of storage systems. However, for example, I'm talking to you through an Apple MacBook Pro, which has a MLC solid state hard drive inside, which I love. Mm-hmm. And it works perfectly for those applications. So you are seeing the spinning hard drives disappear from laptop type situations. Yeah. And of course, nobody's MP3 player uses a hard drive anymore, right?
Right.
That's all flash. So flash is taking over bit by bit, so to speak. But it's not completely there yet.
Got it. And Jason, I think you were raising a question.
I have another question. Let's go back to the 6 terabyte drives for a second, Gary. So one of the concerns we always have with larger drives, especially when the next sort of version comes out, 2 to 3 to 4 to now 6, is the rebuild times on a RAID. We have in the past we've cautioned people against going to those to that next big step, because when you look at potential failure, potentially baking a new RAID, it's really it can cause some pretty big rebuild times. Can you talk a little bit about how Nexsan addresses that?
Yeah, rebuild times are creeping up. Now, first, let's talk about the things that affect rebuild time. Number one, when you go, let's say, from 4 terabytes to 6 terabyte drives, that does not mean 50% more rebuild time. It actually means closer to 25% more rebuild time, because half of the density increase is probably in the linear direction, which means the drives are transferring data 25% faster. So they can then rebuild faster, but the increase in number of tracks that they have does not go faster. So, so really half of the difference is a requirement of additional bandwidth in your system. So what we are seeing at companies like Nexsan, Imation now, is we generally release new controller technologies more or less about the same time that new hard drives come out, so that the controller is faster and can rebuild larger RAID sets faster than before. So the rebuild times are creeping up, but it's not going up as fast as the drive capacities are going up, because we do things to mitigate it, like, for example, making the controllers faster. But there's technologies coming out that we're looking at different variations of, where you thinly spread the drives, the RAID stripes over multiple drives, and then you have a bunch of parallel processors work together to do the rebuild. That kind of thing will be the next generation that cuts the rebuild times down. We're starting to get to a pain threshold for people. It's sort of 24-hour time scales for rebuilds now, and that's sort of getting up to a magic number that people stress out over. So probably before we go above 6, we're going to have to do some other mitigation factors to reduce the rebuild even further.
How are prices, shifting as these larger capacity drives come out? Are we seeing large swings for those larger capacity drives, or are they going to come down relatively quickly, in your opinion?
There's certainly a premium to start with. I did a calculation the other day for somebody where I looked at the cost of per terabyte of our 4 terabyte systems versus the pricing we came out with for the 6 terabyte systems. And the 4 terabyte systems were significantly cheaper per terabyte right now than the brand new 6 terabyte systems. Now you'll find in some number of months, those will be equal, and then they'll cross over where the 6 terabyte then becomes cheaper per terabyte. But right now there's a premium for the 6 terabytes.
Although, that may be mitigated by the physical space someone has access to, or the cost.
Or the power.
Yeah, exactly. Those things may, supplant those increases in the drive, costs themselves.
Sure.
So
also, there's a certain amount of benefit to be had from just having one box. So like a 360 terabyte box, you can say, okay, this is my shelf. I don't have to worry about managing multiple shelves. There's just a shelf. Where we can accommodate more people's storage requirements with a capacity like that than if we just had, a 240 terabyte shelf. I'd just say only 240 terabyte shelf. The 360 terabytes, now that you put 2 expansions on there, now you've got over a petabyte in 12 U of rack space. And I don't know about you
that's
Nick,
insane.
but
Yeah, that's pretty neat.
well, I'm getting so old. I remember when a petabyte was a lot of data.
yeah, and it was a room full of machines,
Right.
And
Or completely unattainable at one point, right? When I started doing hard drives, my hard drives were 5 megabytes, and they were 14 inches in diameter.
yeah, absolutely.
Yep.
He's going to start talking about, like, what was it, the block memory, or the with the little magnets on the wires, or
Oh, when I actually
core memory. That's it.
core memory. I did core memory. Core memory was cool because you could actually like load a test program in one core card, and you could take it out of your computer and walk it over to a different computer and plug it in and run that test on that computer and fix it.
It is amazing how quickly it's changing. And I mean, what you were just kind of hinting at with what we might see with hard drive capacities over the next few years, it's still at that breakneck speed. And I think it's funny because every time you get hints from the industry that we might be hitting a wall with certain capacities, it's like, oh, magically, some new breakthrough has occurred, and now we've got a whole bunch of extra headroom ahead of us.
And we've got breakthroughs coming in several areas. I mean, on the host interface side right now, I noticed that the new Mac Pro doesn't have a 10 gig option built in. That's sort of a shame. But of course, Atto popped up immediately with a 10 gig to Thunderbolt 3 or 2. Thunderbolt 2.
Yeah, 2.
So Thunderbolt 2, they also did a fiber channel interface for it as well. So like if you don't mind an outboard box, you get your 10 gig port. Then we have 10 gig on all of our products available. And then 40 gig is coming pretty soon on the Ethernet side. And then we're now shipping some 16 gig fiber. So the fiber channel is getting faster. On the disk side, we're currently using SAS interface SSDs. And we had tried some SATA ones in the past, but they were pretty horrible, so we never really deployed those. But we're using SAS for that. But there's a new generation of that coming. The new generation of SSDs is using a 2.5-inch form factor technology called Non-Volatile Memory Express, NVMe. And NVMe uses a couple of lanes of PCI Express Gen 3 and gives you a couple gigabytes a second of bandwidth to each slot. But more importantly, the latency is much less because now, instead of doing the unnatural act of taking a flash memory device, converting it to a disk drive protocol like SATA or SAS, and having a maximum number of IOPS that you can do to a drive to be maybe a couple 100,000 or something like that. Now, with the NVMe technology, people have announced 1 million IOPS drives. And this is for a drive that's small enough you could put 3 in your shirt pocket.
I mean, that's insane.
Yeah.
That's insane.
It's really something.
Now, and we actually have one in our possession that's doing 400,000. So it's a technology for late next year, but you'll see more announcements. Dell announced a server that had a couple slots for it, and then other people will be making announcements about NVMe type devices. So there's a next generation of that coming. They'll be pretty expensive to start with. and they're really for high IOPS requirements. By that I mean high random IOPS. Probably not the most cost-effective thing for sequential transfer type applications.
But for
like
massive database applications, things like that, that starts to become really useful. Yeah.
Yeah.
Indexing, maybe transcoding, possibly.
Yep, absolutely. Now, we've talked about the performance of the drive mechanisms. We've been talking now about the performance of the kind of internal, interconnect technologies that the drives connect inside of the storage units to the RAID controllers. We talked about the performance of the RAID controllers, and a moment ago we were talking about increases in kind of the host side connectivity, with increases from 1 gigabit to 10 gigabit and soon 40 gigabit. And on the fiber channel side, we've obviously seen 4 to 8, and you alluded to 16 gig, outfitted RAID controllers coming soon. This is a lot of areas you have to balance when it comes to engineering a system that is maximizing the possible performance. I mean, I'm really curious to get your sense of things, inside today's units and even tomorrow's units, out of that whole string of potential performance, bottlenecks across the system as a whole. Are some areas lagging behind others? What really represents the true performance bottleneck primarily across all of those various, interconnects and points of limit, so to speak?
Well, you'll often find that it's the RAID engine itself that's the bottleneck, but really what we're trying to do is balance all of these things together. So when we're proposing a product for the future, we sit down and try to balance the front-end performance and the back-end performance and the engine performance by selecting the least expensive piece of technology that will balance the other pieces. So, I mean, I could stick a processor on there that was 100 times more powerful than it needed to be, but then that's wasting everybody's money if it's bottlenecked on the front end or back end. So the engineers sit down and they say, okay, we need to do so many IOs a second and so many gigabytes a second. Let's make sure the memory can do it. Let's make sure the PCI Express lanes can do it. Let's make sure the host front end and back end can do it. And if you do your job right, all those things will be more or less matched. Never exactly, because there's variations in customer behavior, but you try to make sure that they more or less match each other. And then that represents a product point that you release when you can do that.
Got it. Mm-hmm. And that makes perfect sense from an engineering and, balancing the engineering with, price consciousness perspective. And again, another thing we've loved about the units that you guys sell, they are engineered extraordinarily well and kind of in synchrony, internally unto themselves, but also you guys are very price competitive with anyone else out there. I mean, it's frankly, what we consider enterprise class storage, no question, at the price of, some other manufacturers out there that I wouldn't necessarily apply that moniker to.
Well, certainly appreciate that. There's a lot of good people doing a lot of hard work. And I think one of the biggest advantages we have is we tend to make things in-house. So we design our own RAID controller. We write the firmware. We design the chassis. We build them, test them, ship them, right? So we don't bash the sheet metal here. We subcontract that. We don't make our own circuit boards. We subcontract that, but it's our design, and we design the chips and the software on it and so forth. So that allows us a great deal of control over the product, and it makes the customer closer to the engineer. There are a lot of companies out there that OEM everything, that the controller is from one company and the box is from another company and the software is 3 different companies bolted together and so forth. And we've sort of played in that kind of a world ourselves, and anytime we ever have, we've regretted it, because it's very difficult to support a customer well when you've got sort of a Frankenstein system like that.
Cool. Gary, talk a little bit about your NST series, your file servers. Just tell us a little bit about that solution.
We've been talking about the E-Series. E-Series is E-Series V now is it's a SAN storage. So it's fiber channel, iSCSI, or SAS block storage. In other words, there's no file system on it.
Right.
If you want a file system, you need to have something like StoreNext, or you need to attach it directly to a server and create a file system. We have a product called NST, and it's NST 5000, NST 6000, some more models about to be released in a few months. And NST is a unified hybrid storage solution. So unified meaning that it does block and file. So it does CIFS or SMB. That's for your Windows people. It does NFS for your Unix people. And it does fiber channel, iSCSI, for the block storage, SAN type people, as well as FTP. So it does all those protocols in one product. And all those protocols are sharing one set of hardware and one set of storage. So you have a bunch of disks on the back end that are virtualized into a big resource that you carve out as you need for either the SAN or the file storage. And the hybrid part of it is we have an option where you can stick in solid state storage, and we will automatically cache your data into two different tiers of solid state storage. We have the RAM tier and the flash tier. Typically, the RAM tier is used for write cache data, and the flash tier is used for read cache data. And this solution can scale from a few tens of terabytes to about 5 petabytes under one unified management console. And there's a ton of advanced features like snapshot, replication, thin provisioning, compression, and other things like that that are more to come. It can do synchronous replication in certain situations. And there's quite a variety of price points and performance points that are available. And since 10 gig Ethernet is now fast enough for most video workflows, you're starting to see more adoption of this type of a product in big video houses like NBC just did the Olympics in Russia. They had an NST system they talked about in some press article we had nothing to do with. They put it in the article. They talked about how they used it and they were happy. It replaced their previous StoreNext solution. And the neat thing about NAS is it is automatically a shared file system. So long as you can talk to a NAS device, you can talk to it. You don't need any client software to make that work.
Yeah, we've done less with your NSTs, and as you know, we often are putting StoreNext, as the file system on top of the E-Series, but we do certainly deploy NAS's file servers, with Ethernet connectivity into some of the smaller shops that we cater to, but we've always kind of had the NST in the back of our minds as, well, if a bigger type outfit was really, really serious about doing an Ethernet-based, video storage infrastructure, it's kind of probably what we would want to test with them. And it sounds like some folks are doing that very successfully. I mean, can some of those engineering features like snapshots, replication, the caching tiers potentially cause problems in environments that are mostly oriented around sustained operation or sequential operations instead of random? Or do you think the NST can truly, handle it all, so to speak?
Well, I think that both the E-Series and the NST support snapshot and replication. The challenge with replication with the video market is you video guys generate a lot of data, and a lot of people's WANs are not ready for that kind of data to be transferred across them. So, it's nothing to generate 5 terabytes of data for a little video project. And transferring 5 terabytes over somebody's shared WAN that may be the telephone system for the company and everything else might make you very unpopular in your organization. On the other hand, there are people who have tons of bandwidth between sites, and or the sites are very close together, and you can run a private optical cable between 2 buildings, for example, and replicate between them. Then you start seeing a more sensible use for it from the video world. In my experience, video people don't typically use replication. It's not just the mechanics of replicating that much data. It's legal issues. I recently went to Technicolor, and their security was more stringent than when I went to the NSA. I mean, they do not want data going out of that building. And they are real serious about that. So letting somebody's latest Disney film travel across the internet to some other location is something that they have to have a whole lot of assurance over before they'd ever let that happen. So I haven't seen a lot of people asking for us to do replication for them in the video space, but the technology is there if it comes in handy. Snapshots work fine on video. There's no issue there. Things like you see a lot of people talk about data compression and deduplication. Got to warn you that most video data is not dedupable or compressible. And so a lot of vendors who the performance numbers they give you assume a certain compression ratio, or the capacity numbers assume a ratio. You got to discount all of that because that's not going to work for you in the video space.
Yeah, absolutely. Right. Now, you had mentioned 40 gig Ethernet. And, I envision a possible future storage scenario amongst some of our larger clients and post-production work groups. and only having a handful of 10 gig links between something like an NST's, head node server and the Ethernet backbone, if you will, of their private video Ethernet switching environment, might not be enough. How soon is 40 going to be out there, available, quasi inexpensively on, some maybe medium or higher end switches? Is that something we're going to be seeing, this year? Is it out now, next year? And when are you guys going to be, making it widely available across, especially the NST product range?
Well, Nick, I really wish I could say it was going to be this year, but I don't see it. And I'm not even sure it's going to be next year. Everything is so expensive, and so few people have the infrastructure available right now. But we're watching the situation. It's just a different plug-in card from our perspective, but there's no point going through all the qualifications and putting in $1 million worth of test equipment if no one has any use for it. And that's one of the downsides in the larger shops, and why StoreNext continues to be a great solution for a lot of people, is if you need a lot of gigabytes a second, that's probably way cheaper than doing something with Ethernet.
Yeah, we're having that dialogue now with several people that we work with who are, really needing extreme high performance because they're building storage systems that involve both kind of quote-unquote post-production activities, but also a lot of transcoding and a lot of big file transfers in and off of the file system, which, as you know, can just saturate the performance that you give whatever machine is doing those transfers or those transcodes. So, yeah, I mean, it's all about finding the right solution for the environment and thinking it through very, very deeply. And one of the things we love about having you guys in our arsenal of core vendors, frankly, is you have the solutions that kind of run the gamut when it comes to disk storage. It's great. From an archival perspective, we don't have to go into a lot of detail on it, but it's something that's probably worth talking a little about. We do still deal quite a lot with tape, and I think as kind of a quasi-active archive medium for, especially in post-production environments, or even, maybe just longer-term archival storage, to us and a lot of our clients, it still makes a lot of sense. But you guys do have this other line of products called Assureon, and it's kind of disk-based archival storage, which, on one level seems a little, counterintuitive to my mind. But maybe you can go into, I know that you guys have designed it in such a way where you're taking some of those things into account, and some of disk's issues with longevity into account when you design the system as a whole. Can you talk a little bit about Assureon? We get a lot of questions from people who want to use disk as archive, but you guys have some experience building a system that's dedicated towards that, and there's certainly some kind of caveats and extra engineering that goes into that, right?
Sure. Assureon is a product we launched about 9 years ago, and we've continued to upgrade it. It's Assureon is at version 7 now, and 8's coming. It's effectively an archive using hard drives designed for protecting your most valuable digital assets. It goes to a whole bunch of things to make sure that all of your assets are accounted for and are not tampered with and are retained through the end of the retention period. So basically, imagine how there's a couple different ways it could work, but basically, let's take the NAS implementation as an example. So you write a file to what looks like a NAS share. It's not really, but that's what it looks like. So you write a file to it. As depending on which directory you stored it into, that will assign different retention rules. So a retention rule might say, retain this file for 5 years, which basically means nobody, not even the administrator, not even a Nexsan engineer, can delete that file until 5 years has gone by. It's also protected at a very high level against any kind of malicious computer attack, worms, viruses, that sort of thing. So even if you're the super user of the system, you do not have the ability to delete a file until its retention period has expired. And this protects you against inadvertently deletion or inadvertently modifying a file before you're allowed to do so. And a lot of companies have, some number of years as a retention policy. And then we also have, for people who don't really have that strict of a policy, we have it so that you can have a user overwritable or administrator overwritable retention time. And if you were to try to write another version of that file with the same name and the same location, it would save the older one and create a new file So you'd have versions that it would keep. So you have no ability to change or modify the data, and that guarantees that it has integrity. And then everything has got digital fingerprints on it, and there's an auditing process that goes through every 90 days or so and makes sure every file is there because they're serialized, and it makes sure every file is readable and matches the original cryptographic hash that we took of the file. And the Assureon, there's always at least 2 separate copies of your file in 2 different nodes.
Mm-hmm.
So if a file turned out to be corrupted or missing, we could repair it from one of the surviving nodes. So Assureon typically is used for medical records like CAT scans and PET scans and stuff. It's used for financial records. The FAA uses it to store aircraft maintenance logs. It's used by some legal organizations to store legal documents. And we have just started to sell it into the media and entertainment space where people have high-value original content they want to guarantee does not get inadvertently corrupted either due to user errors or any other kind of mechanical or electrical problem. No matter what user mistake is made, no matter what administrator goes crazy, no matter what customer hacks into your network, whatever, it's designed to protect you against that kind of situation. And the integrity level is so high that we typically don't have people back up the Assureon to tape. It supports it, but that's not normally necessary. The amount of safeguards and protection in the system is sufficient that you no longer need to back this stuff up. And so that brings us to the other part of the Assureon story is it's used for storage optimization. You migrate your unchanging data off of your tier 1 expensive storage to the Assureon for safekeeping. The data is much safer inside of an Assureon than it would be, say, sitting up on your HDS system.
Sure. But from a pricing perspective, you've talked a lot about both from the redundancy standpoint, having multiple copies, so you're taking up more space for that data, as well as some very kind of fancy engineering that goes into all of these policies and the policy-driven retention systems and, all from an administrative standpoint. So where does it price out versus just raw block storage?
Yeah, I don't have the numbers in front of me, but just a rule of thumb, it's probably 3 or 4 times the price of for the same amount of E-series storage, because we got to store 2 copies, then there's servers attached to that and software. And the price per terabyte, the file size makes a difference. So because there's overhead attached to every file, there's encryption keys, there's metadata records and so forth. The smaller the file, the bigger the overhead. Video, it's not an issue because your video files are so huge. But it's certainly significantly more expensive than either E-Series or NST. But it's less expensive than a lot of other systems that people use, and it doesn't require a lot of labor from the customer. Once you've set it up, it just looks like a big bucket you throw your files into that are protected.
Gary, what are you looking at as far as like a drive lifetime on something like that? Is that something you're swapping out on a regular basis, or?
Yeah, it has built-in migration tools, so the customer will typically install a new generation Assureon node and simply transfer the files from the old one to the new one.
Wow.
Is it object storage?
Internally, yes, but we hide that from the customer. So it's got a CAS archive system inside, but we've always felt that the mapping layer between the customer-friendly username or file name and the CAS object identifier, sometimes called a token or a ticket or whatever, that is where the security protocol needs to be. So that we keep under the covers. So the mapping between myfile.doc and the hash code for that file is protected internally to the Assureon to prevent people from playing with that database. If you imagine if that database was outside in an unprotected ordinary server, that I could modify a file or make it look like I modified a file simply by changing the token that was associated with the file name that you were looking up in the database. So that security wall needs to be on the mapping layer between the file name and the token.
Absolutely. And I mean, again, if you're spending millions of dollars on productions, either for broadcast, scripted dramatic stuff, Hollywood, theatrical cinema, and, again, you may be spending tens or even hundreds of millions of dollars, and this is where the studio master lives. It sounds like a really appropriate system, if that's the type of video that you're dealing with. Yeah. But for some customers who maybe, the cost of their productions is much lower, other types of disc-based archive, or rather tape even, or other just mediums or approaches in general might be more appropriate, right?
Sure, and I think what you see in the media world is there's still a mindset of, hey, if it's more reliable than tape, that's good enough. And that's a pretty low bar, right? So it's hard to sell a lot of video people on ultra, super, uber reliability because they're so used to something that's so unreliable to start with.
Yes, the problem is almost none of our clients shoot on videotapes anymore.
Usually the tape is on the other end of the process now. It's on the archiving side. So that's where they invest in the dual writing drives, where you're writing to two tapes at once, exactly the same data, so your archive is also backed up.
But yeah, you'd be surprised, even frankly at the consumer end, to be sure, but prosumer and industrial video and corporate production, all the way up to broadcast and theatrical, the vast majority of it exists as a file from the moment it's created. And so, people... It's been a trying decade during my time here at Chesapeake. I mean, again, people used to rely on those videotapes probably lasting a good 15 to 20 plus years. And now there's this file that's this just amorphous, kind of hard to put your finger on thing that they need to preserve just the same way that they preserved those physical things, or what they thought of as the physical media. But now there's really nothing physical. It's just this file somewhere.
Mm-hmm.
And this is coming back to our original thing about flash media. And so, okay, great. You got this camera. It's got a flash stick that sticks in there, or a flash cartridge. That's great, but they're so expensive, everybody has to reuse them.
Right.
In the tape world, you simply took the tape out and you gave it to somebody and you put it in a vault because the tape was $5.
Right.
Now you got this memory cassette that's $300 or $400 or something, maybe more. And so the impetus is to get the data off of it and reuse the cassette, right?
Absolutely, right. Absolutely. And it presents a lot of challenges. And again, as we wrap here, and this has been just an extraordinarily informative conversation.
It's been amazing, Gary. Thank you.
It's why I always love talking to you and picking your brain about these things, because I walk away from the conversation at least allowing myself to present myself as being smarter than I really am. So thank you for that. Thank you. But that's why we love your stuff. That's why we love the Nexsan stuff. Again, as people are in this realm now where their content is as valuable as ever, it's a file. They need to trust that where it lives is going to be highly, highly reliable.
They want to know that you've done, what you need to do as the manufacturer of their storage to make sure that they don't have to know or worry about any of that.
Exactly. And so, everything we've talked about today is just all of that back-end stuff that goes into making highly reliable and fantastic storage systems that we have sitting in our office and coming in and out of here on a pretty much daily basis. So we really appreciate that. We appreciate the partnership with you guys. So thank you so much for being on today, Gary Watson, CTO of Nexsan, and we look forward to seeing you and speaking with you in the future, Gary.
And thank you, Nick. And now I'm actually an Imation Fellow. That's my new title now. Now that we've been, our new corporate overlords have taken over.
Well, the next time I see you, I'll say, my good fellow.
That's me.
Awesome. Thanks so much,
Thanks,
Gary.
Gary.
Thank you, Nick. Thank you, Jason.
Take care. Bye-bye.
Take care.